Today you will be learning about metallurgy of iron. First, we have to decide how to go about. Various metallurgical operations are concentration of the ore, conversion of the concentrated ore into its oxide, reduction of the oxide, and finally refining. The various minerals of iron are oxides, carbonates, and sulfides. In the oxides come magnetite with the formula Fe3O4. Hematite has the formula Fe2O3 and lemonite has the formula Fe2O3 3H2O. Whereas the carbonate ore is siderite with the formula FeCO3 and sulfide ores that are present are iron pyrites with the formula FeS2 and chalcopyrites with the formula CuFeS2. Now, to choose the best method of extraction of iron from its ore, one should take care of the reactivity series. The reactivity series is a series in which the different metals are arranged according to the decreasing order of reactivity. The first element that comes here is potassium. K When we check the reactivity series, you find that potassium comes in the first position. So this is the most reactive metal and the least reactive will be platinum. So you find that the order is K, Na, Ca, Mg, Al, Zn, Fe, Pb, hydrogen, copper, mercury, silver, gold, and platinum. This can be understood very easily using a mnemonics. We have to just remember the name Kanakamagal. Zareen faced a problem in his house, cut huge Argentina, went to Australia to play PT. Okay? Out of this, you find that the only element which is a non-metal is hydrogen. So hydrogen is the standard and the elements before hydrogen that will be called as the reactive elements and the elements which are coming after that will be less reactive or noble in nature. So you find that the reactive metals can be included up to aluminium. These are moderately active metals. Next comes silver, gold and platinum, which are considered as noble metals. Here the reactive metals are separated or extracted by electrolysis, whereas the moderately active metals are extracted by pyrometallurgy. And noble metals, they need to be just concentrated because most of them, they exist in the native state. So now that you have identified that iron is moderately active, it undergoes extraction through pyrometallurgy. We will be discussing about the metallurgy of iron now. The steps followed in metallurgy of iron are: first, choosing the ore. Ore is hematite Fe2O3 with some amount of water molecules. You find first we do what is concentration. Concentration, we can adopt more than one method. It can be gravity separation, followed by magnetic separation. The concentrated ore is then subjected to calcination to remove the volatile impurities. Further, it is treated with a reducing agent which involve the process of pyrometallurgy, and finally we get the product as pig iron. The picture shows a model of the blast furnace. A blast furnace is a furnace which is a steel tower which is lined with bricks all over. Bottom part consists of hot air tires through which air is blown in and the temperature is maintained around 2500 Kelvin at the bottom. And as we move away from source of heat, you find the temperature is keeping on decreasing, and at the top portion you find that there is a cup and cone arrangement. Metallurgy of iron is carried out in a blast furnace. A blast furnace is a huge steel tower which has a provision for adding the charge from the top, and you find that heating is done at the bottom with the help of what is called hot air tires. This tower is lined with bricks so that it can withstand high temperature. The cup and cone arrangement is used for adding the charge inside. The charge added here in the blast furnace include the calcined ore Fe2O3, that is the concentrated hematite. Along with it, we have coke, which is carbon, which is acting as a reducing agent, and we add a little bit of calcium carbonate, which acts as a flux to remove the infusible gangue that is present in the ore. The gangue present here is silica. So you find that this mixture is taken in the ratio 8:4:1 and fed into the blast furnace. You find the heating is done from below with the help of hot air tires. The temperature is at as high as 2170 Kelvin at the bottom part. So then you find that the coke that is fed in reaches here, and the first reaction that is happening here at the bottom part will be carbon combining with oxygen to form carbon dioxide. This is a highly exothermic reaction. As a result, the temperature even becomes greater. This carbon dioxide produced is a gas, so it rises up. As it rises up, it encounters more amount of coke, resulting in carbon monoxide, which is again a gas. This gas is rising up. You find this reaction that is happening in the blast furnace is an endothermic reaction. With the result, the temperature is reduced to 1623 Kelvin. As carbon monoxide rises up, it reacts with Fe2O3 that is present, and it produces Fe3O4 and carbon dioxide. Further, Fe3O4 reacts with more amount of carbon monoxide, producing FeO and carbon dioxide. Later on, you find that this FeO again reacts with carbon monoxide, forming iron and carbon dioxide. So then the temperature is around about 1123 Kelvin. That is, towards the middle part of the blast furnace, the reaction occurs, and towards the middle part itself, the calcium carbonate that is added as the flux undergoes decomposition. So, calcium carbonate, when it undergoes thermal decomposition, it produces calcium oxide, releasing carbon dioxide. Calcium oxide further reacts with the gangue particle silica, forming calcium silicate. This calcium silicate forms the slag, and the slag will be floating over the molten metal. So you find that towards the middle, you find Fe is produced along with carbon dioxide. This Fe that is produced is in the molten condition, and it will be settling at the bottom part of the blast furnace, and it can be tapped out. Above that, we find the second layer that is formed, which consists of the slag, and which is the slag present here. It is calcium silicate. So why did we use this calcium carbonate? The purpose of adding calcium carbonate is to remove the infusible silica into the fusible form, and the fusible form that is produced is calcium silicate. The final product formed in the blast furnace is pig iron. The composition of pig iron is Fe plus 4% carbon and some amount of sulfur, phosphorus, silicon and manganese as impurities. To get more quality product, that is iron, we are taking pig iron and heating it with scrap iron and some amount of carbon in a reverberatory furnace, and we get what is called cast iron, which is better quality iron which contains 3% carbon in it. Now, to get best quality iron is wrought iron, which is otherwise known as malleable iron, and that is got by heating cast iron with carbon and iron oxide in a reverberatory furnace. This is resistant to corrosion. Hope it is clear. The process of heating the compound with a reducing agent to get the corresponding metal is known as pyrometallurgy.